You're going to be learning about acids and alkalis. Just want to find out what you already know. What is an acid? What comes to mind? Think about that. Can you think of any examples? So I'll be teaching you about the nature and properties of acids and alkalis today. And you're going to learn how to read a pH scale, and I'll also tell you about some different ways that we test liquids to find out if they are acids and bases. So acids are solutions that have a pH, which stands for power of hydrogen, lower than 7. A concentrated acid has a little bit of water in it, and a dilute acid has a lot of water in it. Base. A base is a substance that reacts with an acid to neutralize it. Alkalis are bases that are dissolved in water. Okay, this is litmus paper. It is an indicator, which an indicator is something that will tell us whether the liquid is acid or base. So acids turn blue, litmus paper red, and alkalis or bases turn red litmus paper blue. Neutral, a substance with a pH of 7. It is not acid or alkali. An indicator is a colored substance that shows if a solution is acid or base. Here are 3 examples. We use a universal indicator, which can be a paper or a liquid, litmus paper, and red cabbage. You'll be using red cabbage in your lab. The pH scale. On this scale, 7 is neutral, and acids can range from 1 to 6.9, and bases can range from 7.1 to 14. Water has an equal amount of acid and base. Okay, more about the pH scale. The pH scale is based on a system of 10. So a pH 5 acid is 10 times stronger than a pH 6 acid. A pH 10 base is 100 times stronger than a pH 8 base. So when I say X, I mean the number of times. And an example, Pang is 2 times as strong as Pun. So here's a question for you. How much stronger is a pH 3 acid than a pH 6 acid? Take a look at the pH scale and work this out. Okay, the answer, 1,000 times stronger. You have to move 3 places, so 3 zeros, 1,000 times stronger. Hazard warning labels. There's 4 hazard warning labels you'll need to know. Many acids and alkalis are hazards. The first one is corrosive. Corrosive means that it may destroy living tissue on contact. The next one is toxic, and the synonym for that is poisonous. More on hazard warning labels. Harmful. It may have a health risk if breathed in, taken internally, or absorbed through the skin. And the last one is irritant. It's a non-corrosive substance which can cause red or blistered skin. Okay, foods and products that are acids and bases. Acidic foods are citrus fruits, spinach, vinegar, tomatoes, and soda. Alkali foods include eggs and baking soda. Baking soda is in baked goods like cakes and muffins. And some household products that are basic are ammonia, glass cleaner, liquid soap, and drain cleaner. Neutralization. Neutralization is the chemical reaction that takes place when an acid reacts with a base, making new substances, new products. Acid indigestion, so a neutralization reaction that happens within the human body. Acid indigestion is when the stomach makes too much hydrochloric acid because a person eats too much food. We can take antacid tablets and a neutralization reaction occurs. The extra hydrochloric acid in your stomach is neutralized by the substances in the antacid. These pictures show what happens. Your stomach has a lining, a coating on it. This is mucus, and it protects the wall of the stomach from the hydrochloric acid. Now, if your stomach produces too much hydrochloric acid, it can work its way up the esophagus. The esophagus does not have this coating of mucus, and it will start to irritate the lining of the stomach, causing pain. Okay, another thing we test a lot is soil acidity. So the best soil is a neutral soil with a pH of 7. Acid soils can range from 5 to 6.9, and alkaline soils can range from 7.1 to 9. Most plants like soils that are between 6 and 7. If you need to change an acidic soil, you can add lime, which is alkali, to neutralize it. So that is the end of this lecture. Make sure that you've written down all of your notes, and I will see you in class. Bye-bye.